All right, we're going to be working on the Chapter 9B study guide today. First, notice that this is actually part of the question. It won't be like this on the test. I apologize. So, identify the asymptotes of minus 4 over x minus 3 minus 2. Well, we know that the x equal asymptote, which is, okay, first we make that denominator, the x minus 3, equal to 0. We solve for x, and we get this is our x equal asymptote. Well, if we look at our options, there's only one with x equals 3. So the answer has to be D. All right, number 2, which of the following is a discontinuity? Well, the discontinuities, again, are where we have a denominator of 0. So it's at x equals negative 2. We haven't identified exactly what type of discontinuity, but that's not what it's asking. So this question would be 2. All right, now we're going to look at number 3. Which equation has a graph like the one below? Well, first we're going to look at our asymptotes. Okay, so we have a x equals 1 asymptote. If I subtract the 1, that's going to be in my equation, x minus 1. Well, again, I only have 1. But let's look at our other asymptote. I also have a y equals negative 3. Well, that then has to be my k. So I have to have a minus 3 at the end. And sure enough, C fulfills both of those conditions. So C would be my answer. All right, state the horizontal and vertical asymptotes. Horizontal are my y equal, and vertical are my x equal. All right, so x minus 2 has to equal 0, which means that x equals 2 is my vertical asymptote. So now when you take this test, if you want to use different colored pencils for like your asymptotes, grab a red pencil and use it for asymptotes, or a blue pencil and a black for regular test, that's fine. I kind of like it separate colors, but I use a dotted line since I don't have a separate color right now. All right, so my y equal is my k. So I have a y equals 1 asymptote. Okay, y equals 1, x equals 2. All right, so those are my 2 asymptotes. Now, to graph this, please make sure you read the entire question. I have to graph it also. I need an x, y chart. I'm going to choose x's on either side of my asymptotes. So that means I'm going to choose 3, 4, 1, and 0. Okay, so 0, 1, 3, and 4. So 0, if x is 0, whoops, I have to go back up and look at the equation. If x is 0, I get 2 over negative 2 plus 1. Well, that's negative 1 plus 1, which is 0. Okay, so 0, I'm going to erase my funny little tick mark there. At least I'm going to try. There we go. Okay. I go through 0. Now, if I plug in a 1, I get 2 over 1 minus 2 is a negative 1. So that gives me negative 2 plus 1, or negative 1. So 1 gives me negative 1. All right, I can see my line. It comes right along the asymptote. It arches out, catches these 2 points, and goes back down the other side. All right, now I'm going to find the 2 points on the other side of the x-asymptote. If I plug in a 3, I get 3 minus 2 is a 1. So I have a 2 over 1 plus 1, which is 2 plus 1, or 3. So I go through 3, 3. Right there. Now if I plug in a 4, 4 minus 2 is 2. I end up with 2 over 2 plus 1, which is 1 plus 1, which is 2. Okay, so I also have this point. Now again, I can see my line. It comes down the asymptote. Whoa, that one is not nicely done. We're going to curve it a little better. I come down my asymptote, swing out, and I go on. There we go. That's my graph of this function. I have identified my 2 asymptotes. Okay, I've got everything I need to do to prove to my teacher that I know what I'm doing. Hint, hint. All right. Okay. We're going to look at this. Okay, so I'm to state the x and y intercepts. That's critical to know, not asymptotes, but intercepts. Okay, so the x-intercept, I'm looking for where x equals 0. So I plug in a 0, I get 0 minus 6 over 3 times 0, which is 0, minus 2. Well, this is just negative 6 over negative 2, which is 3. So my x-intercept, x is 0, and y is 3. My y-intercept, pardon, I did that backwards. That was my x-intercept. Okay, let's see what we've got here. Where's my eraser? There's my eraser. Okay, so I apologize, but there you go. It's been a while. Y-intercept, and this is the x-intercept. X-intercept is when y equals 0. Okay. If you remember, the reason for all of this is when I cross the x-axis, y is 0, right? When I cross the y-axis, x is 0. So y is 0, which means that x squared minus x minus 6 over 3x minus 2 must equal 0. Okay. In any fraction with a variable in the, well, it doesn't matter what the denominator is. You're not going to be able to divide by 0. That's not what you're looking at. When you need a fraction to equal 0, you need the numerator to equal 0. So we're really just going to look at what makes that 0. That's a quadratic, so I'm going to factor it. Factors of 6 that subtract to 1, 3 and 2. So I'm going to have a 3 and a 2. Now, this symbol, this negative, tells me the larger of those two has to be negative, so it's going to be negative 3 and a positive 2. Now, what I'm looking for is when these are 0. So x has to equal 3 or negative 2. Those are going to be 2 x-intercepts. Okay? So we're going to have 3, 0 and negative 2, 0. Now, just so my teacher knows I know what the answer is, I'm going to put a box around them. I'd hate to lose points because I didn't circle or box my answers. All right. Identify all asymptotes and intercepts, then graph. Okay, so what do I know about intercepts on this function? Well, first off, I know that x plus 2 equals 0 means that x equals negative 2 is an intercept. So, not an intercept, an asymptote. That's my asymptote. Okay. Let me get this all on my graph. And this, just in case I'm not accurate with my drawing, I'm going to write the equation here so that my teacher knows that I know the equation for that asymptote. Now remember, to find the y equal asymptote, we force the two to be equal. So I'm going to put a 0x squared down here, circle the coefficients. I get y equals 1 over 0, which means I'd have no horizontal asymptote. Okay, now I have to divide this in order to find my slant asymptote. X squared minus x minus 2 divided by x plus 2. So, I need an x. That gives me x squared plus 2x. But I am subtracting, which makes that a negative 2x. Negative x and negative 2x is negative 3x. Bring down the minus 2. I have a negative 3. And I get negative 3x minus 6. Well, I can't. This is, if I subtract this, this goes away. I'm adding the 6, becomes a plus. I have 4. Well, I ignore the remainder for my slant asymptotes. This means that is my slant asymptote. So I have a y equals, that's a y equals x minus 3. So to plot this, I plot minus 3, and I have a slope of 1. So I'm going to come up to 3 here. So I'm going to write this here so my teacher knows I know what my slant asymptote equation is. Now I'm going to plot some points. Okay, so now I have x, y. Since I had a positive 2, I have a negative 2. Man, you guys probably already spotted that and were waiting for me to catch up. Okay. Nope, that wasn't the one. That wasn't the one I meant to re-erase. This was the one I mean. Why I ever thought... Why I ever thought that was x minus 2. I have no idea. So we're going to put this next to the x minus 2. Okay, we're going to do that one over again. I apologize. So, x minus 2. Sorry, I was just digging out a ruler so I could make my lines a little better. Sorry, that was the fact that my finger was touching the platen. Okay, now that I have a lovely straight one, let me make a nice straight one over here. Going through 3. Stop it. Wow, that was, oh, that's why. Somehow I ended up not on the pen. Apologies. All right, well, it kind of blew on me, but that's okay. It's hard to do. All right, so I'm going to write box it. Look like I made some other little random marks, so I'm going to try to get rid of them. Okay, that'll work. All right, so now we're going to do our points, x and y. Okay, so I had -2, so I'm going to use 0 and -1, and then -3 and -4. Okay. If x equals 0, yes, if x equals 0, I get -2 over +2, which is -1. So I have 0 minus 1. So it's actually right down there, just above the line. I know it's hard to see. Make it a little bigger. Okay. Now, if x is -1, -1 squared is 1. I'm going to have to blow this up a little bit so I can write better. 1 minus a -1, so that's 1 plus 1, minus 2. Well, that's 0. 0 over anything is 0, so I don't need to worry about what the denominator would have been. So on the x, I have -1 and then 0 on the y. So it's actually right up here. So if we can see this, actually I'm going to do purple line because I did my red asymptote. I'm going to be coming down along this asymptote. I swing up, catch this, and go back up the other asymptote. Okay, now let's look at the other side. -3. 3 squared is 9. Minus a -3 is +3. 9 plus 3 is 12. -2 gives me 10. But I have to look at the denominator. X plus 2. So if x is -3, plus 2 is -1, that's merely going to make this -10. Wow, okay, so -3 gives me -10. Right here next to that. -4 is 16 plus 4. That's 20. -2 is 18. So I get 18. Oops, I'm not in blue. 18 minus, nope, not minus. 18 divided by -2. That gives me -9. So I'm right here for this one. Okay, if I'm going to interpret this, this comes down, swings out, and back up. Okay. Oh, well, you know what? That was badly done because I was going up the not up the asymptote. Okay, we're doing purple again. I think I'm going to make it just a smidge thicker so you can see it. Comes down, swings through these 2 points, and back up the other side. Okay. You do the same on this one. So it came down the asymptote, caught the 2 points, and went up the other side. Okay, so that's what this one would look like. All right, we're going to do the other side. I'm going to split this video in 2. It's going to be too hard to upload it if it's too big. So you'll get 2 different pieces. Okay. Write a rational function with no discontinuities that has roots at 3, 0, and -2, 0. Well, whoops. Let's take that down a notch. Okay. Okay, so I have x -3 and an x minus 2 are my zeros, right? Are going to be, sorry, discontinuities. Oh, with no discontinuities, that has roots at 3 and negative 2. So these actually are my zeros. So my numerator is going to have to be this, which is going to give me x squared minus 5x plus 6. That's got to be my numerator. Now, to have no discontinuities, I believe I'm going to have it. Okay, to have no discontinuities, I need something that has no 0 to it, right? So something like x squared plus anything. It's going to have no zeros because otherwise they'll be imaginary. Remember? So just something like that at the bottom, you're fine. There's no discontinuities, and this would have roots at 3, 0 and minus 2, 0. So I'm going to put a box around it so my teacher knows I know what I'm doing. Okay, list the vertical asymptotes. If you forget, just remember vertical, it's crossing the x-axis, it's an x equal. Okay, so the x equals are by setting the denominator equal to 0. In this case, I'm going to have negative 6, 6, and negative 2. Booyah! And you're done. See, that one was super easy. Okay, I'm going to pause and put the last part of this on a separate video.